Gabe. Emily, Haley, and Gabe, we miss you. We're going to give a shout out to you.
Hey guys.
You don't even know who that was. Identify yourself, strange person.
Megan Lindley.
She's excited to be in Class A because she just got a super grade on her test. Way to go. Way to go. Connor, who do you want to say hi to?
Sup, Haley? Hey.
Actually, we don't really have that much exciting. The exciting part is yet to come when we talk about side-side angle or the donkey. Here we go. Right here. Side-side angle. It's a problem, isn't it? Backwards spells donkey. This is where we get the ambiguous case. This is what we have to understand. You remember in geometry that you could not use side-side angle for the purpose to find an angle. This time the angle is not included between the two sides. Say we have a 30-degree angle, okay? And I'm going to make a side of 10. This first part is by far, again, the most important part for you to focus on, okay? Suppose I have a leg opposite the angle that's shorter than the other leg. What would be a length shorter than 10? 5. That might be too short. We'll get to why that occurs. I'm just going to choose 8. Okay, I need a volunteer. Lindsay, you tell me when I got a segment that's approximately 8 units in length. Okay, are you ready? All right, I'm going to grab my handy-dandy segment maker. Shorter? Like that? Okay, you're okay with that. Okay. All right, so if that's 8, everybody agree with that triangle? That could be a triangle right there. Now, watch this. Do you see how that side-side angle? That is a triangle that has a length of 10, a length of 8, and an angle of 30. I will make another triangle that does not look the same that also has a length of 10, a length of 8, and an angle of 30. Are you ready? I'm going to swing this on a pendulum. Same segment, same length, right? Still 8, still 10, and still 30. So you've got one here, and you've got one here. That's why side-side angle does not allow us to make congruent statements. We don't know if it's this triangle or if it's that triangle. Does that make sense? So again, the side, what's the length of the side opposite the angle? 8. Is that shorter or longer than the other given side? Shorter. If it's shorter, you might end up with 2 triangles. So what I'm going to do is, to show this, I will just simply, in this case, to make my point, draw the 2 triangles. That was one. And then since we're tigers, we'll do red and blue. That will be the other. If you have an opposite leg that is shorter, you might get 2 solutions. That will be 2 triangles. And that's because of the pendulum swing. That pendulum swing creates 2 triangles. Got it? Let's look at another scenario. Now I'm going to do a side opposite the angle that is also shorter. But this time it's going to be too short. For example, what might be a length of a side opposite 30 that might be too short to actually make it down to the other side? Yeah, say 1 or 2. So if I just simply, well, we'll do this first. So we'll do a length of 2. If I grab a segment and I, can kind of hang off top from here, Well, look, I'm trying to reach down there. I just can't do it. Okay? Just won't make it, will it? So that's a case where no solution. Opposite side is too short. Opposite side is too short. Got that? Okay. Flip it over. Now we're going to look at where the opposite leg is longer. So, again, I'm drawing a dotted line because we don't know how long that segment is. All we know is that it helps form a 30-degree angle. And then what's a length longer than 10? Sure, 20. We'll go with 20. Great, good time. What? No, I'm just showing you 3 examples that have a 10 and a 30 that work out a little bit differently. Okay, so here's a 10 and a 30, and now I'm going to take and stretch it a length of 20. That's about 20. So that's a triangle that's formed. Well, you say, well, try to swing it on the pendulum. Well, when I do, I mean it's back over here, isn't it? I mean, it kind of undoes my triangle. I don't have that 30-degree angle anymore. So that's problematic. So as you look at this, the pendulum swing does not give you a second triangle. So when the side opposite the angle is longer, you just get one solution, one triangle. What do you think? Ooh, pretty easy. Who said that? That one right there. All right. Just kind of mouth. All right. Okay. Go ahead and take out your look at the back sheet of notes. Okay. This sheet that I'm pulling up right here. I love this. The reason why I love it is, well, first of all, I made it, so I think it's cool to make stuff. Second of all, students seem to connect with this. This seems to work. So yesterday we said angle, angle, angle. No solution, right? Because like you can't solve the triangle. So like if I give you a problem, solve the triangle like you did yesterday in your assignment. If you're given 3 angles, yesterday you're given 2 angles of one side, correct? If you're given 3 angles, you have no idea how to find one of the sides. It could be a triangle that fits in my hand. It could be a triangle that takes this whole room to fit. You have no idea about the size of it, do you? Okay? So, angle, angle, angle. Similarity we can prove, but nothing beyond that. Yesterday, I gave you all problems at 2 angles, correct? True or false? In a triangle, if you know 2 angles, you know 3. Well, yeah. So these two really state the same thing. You got 3 angles in one side. It doesn't really matter if the side's between them or not. But this is different. This is 2 sides and an angle. Okay? Yesterday, 2 sides or 2 angles and a side, 1 solution. Use the law of sines. No big deal. This one, if the side is in between the 2 angles, still 1 solution. Use the law of sines. Good to go. Today, side, side, angle. Look at how we go down the decision tree. When you end up with that scenario, you go down here and it says, is the side opposite the angle shorter than the other given side? Or is the side opposite the angle longer than the other given side? We just talked about that. If it's longer, there's 1 solution. Use the law of sines. But if it's shorter, then you either got no solution or 2 solutions. That's what we're going to do today. We're going to do 1 of each, and you'll see how they play out, okay? So for your notes for the test, this is what you want to be able to navigate through. Does that make sense? Let's navigate. Booyah. Solve the following triangles by classifying them, which of the 5 cases it will be. I'm not going to give you on the test. I'm not going to say, hey, look at this side-side angle situation. I'm just going to say solve the triangle. And you got to understand which of the 6 it is. Actually 5, because we never do an angle. So here we go. Angle A, angle B, angle C. Angle A is 42 degrees. Angle B, we don't know. Side B is 12, and side A is 22. Plus. Is this a angle, side, side angle? What is it? Side angle, because you got 2 sides, and the angle is not included between them. Okay? So, I go to my decision tree. My decision tree says it's side angle. First, I must determine, is the opposite angle longer, or is the opposite side longer or shorter? Opposite side longer or shorter? Which one is it in this scenario? Opposite side longer. My decision tree tells me there's how many solutions? 1. So we just set it up like we did yesterday. It's no big deal. A, B, C, little a, little b, little c. Angle A is 42 degrees. Side B, 12. Side A, 22. So which of the 3 missing components will we be solving for in this scenario? Angle B. I take the sine of 42 divided by 22 is equal to the sine of B divided by 12. This is different because we're solving for an angle. Notice what happens. On my calculator, take it out, and I take sine of 42. Make sure you're working in degrees and not radians. I divide it by 22, and I'm going to multiply both sides by 12. And I get this, 0.36. If you write down the decimal, you must write it down to 4 decimal places in order to be accurate. 0.3650 is equal to the sine of B. Correct? Let's think about that for a second, folks. You just took a test on graphing, sine, and cosine. Okay, good idea. Before we do that, you just tell me, is it possible for sine to even be equal to 0.36? What's the biggest sine can be? What's the smallest? -1. Is 0.36 between 1 and -1? Yes, so we can come up with a solution. We are going to do our sine inverse. Here's what I do so I can be more accurate. I don't actually sine inverse 0.3650. What I do is I second sine inverse. I go second answer, not entry, but answer, which is the negative key. And that way it just grabs my previous answer and plugs it in. I get 21.41. See how I do that? Second sine, so that's sine inverse, and then second ANS. It's the label right above your negative key. That will grab your answer. But now what mine's going to do is mine's going to inverse 21, because that was my last answer, and that will give me an error. So when I did it up here, I got an answer. Okay. So we got 21.41. I'm happy with that. What can I now find? I can find C. Very good. I find C by subtracting the other 2 from. What did I do? Oh, it's 21, not 24. I was too busy teaching. Good thing Connor's awake. He's on the ball today. He's wearing his Arizona State shirt. Is that where you're going to college? Possibly. Ooh, wow. Minus 42 minus 21.41. Arizona State's a great college. It's just funny because we ask a lot of people why they went there. A lot of times it's not because, it's a great college, because it's boring. It's close to the beach. All right. Yeah, we hear about that. Okay. Now, we want to find C. How will we find C? Use our law of sine. Sine of 42 over 22 equals sine of angle C is 116.59. We're going to divide that by C. So as I solve the law of sines here, (22) times the sine of 116.59. I'm going to divide that by sine of 42. And I get 2940. Side C is my biggest side. Is that my biggest angle? Yeah. Side B is my smallest side. Is that my smallest angle? Okay, so triangle inequality theorem tells us that must be true. Good? That was basically from yesterday. The only thing you learned that was new is we inverse for an angle, correct? All right, try the next one. A, B, C. A is 85 degrees. B is 25. A is 15. Again, which of the 6 cases is this? Side-side angle, right? So I go down my decision tree. It says when I have side-side angle, I must look at the side opposite the angle. Is the side opposite the angle shorter or the side opposite the angle longer? Which one is it? Shorter. Uh-oh, I've either got no solution or I have 2 solutions. So what do? We set up the law of sines. We say the sine of 85 divided by 15 is equal to the sine of B divided by 25. And we cross multiply. Sine of 85 times 25 divided by 15, and we get 1.6603. Can sine be equal to a number greater than 1? No, it can't. That means when I drew this 15, I drew it way too long. It's actually too short. It can't reach down to the other side. It's just not long enough of a leg. It doesn't work out. And to show you that it doesn't work out, it even says on here, it says on your decision tree, when solving for the missing angle, if sine of theta is greater than 1, then there is no solution. It tells you right here. And so as I go back to my board, if I take the sine inverse of that answer, again, I get a domain error because you can't take the sine inverse of that. So we say no solution. What do you think? Correct. You shouldn't get any negatives. Wow. Okay. Here we go. Last one. We got time. We're on a roll. A, B, C. 20.5 degrees is 12. B is 31. I look at my chart. This is a side-side angle problem. And so I ask myself the question, is the side opposite the angle longer or shorter than the other given side? Shorter. So therefore I either have no solution or 2 solutions. All I can do is set up the law of sines. Sine of 20.5 divided by 12 is equal to sine of B over 31. Set it up. (31 sine of 20.5). And I divide that by 12. Can sine equal 0.9? Yes, it can. So it's not going to be a no solution. It's going to be a 2 solutions. Sine's positive, right? Which quadrants is sine positive in? 1 and 2. Are angles acute or obtuse in the first quadrant? Acute. Are they acute or obtuse in the second quadrant? Obtuse. See? So when we're solving for angle B, you're going to come up with one angle where sine was in the first quadrant where it's acute, and one angle in the second quadrant where it's obtuse. So at this point, when you recognize that you've got two solutions, you set up two triangles. Our first triangle is where B is acute. Second one is where B is obtuse. And we list all 6 pieces for each one. True or false? We already know angle A. True. It's 20.5, and it's the same for each one. That doesn't change. Do we know angle B? C? Do we know side A? What's A? 12. Same for each one. Do we know side B? 31 for each one. So see how those triangles are similar? They both have those 3 pieces, just like I talked about with the pendulum. Now what we have to do is we have to come up with angle B. So here's how I will do it. I will sine inverse that 0.9. I get 64.78. Is that acute or obtuse? Think about it. How would I come up with the obtuse angle? If it's in the second quadrant. Okay, you got to watch. Got to come up with it. If that's my acute angle, the obtuse one would be over here, right? I subtract it from 180. So all you do, and it says that in the notes, it tells you exactly what to do. So what we're going to do is we're going to take one angle is 64.78. The other one, what? Because it's 64.78. That is acute, right? Minus my 64.78. What? Yeah. Not necessarily. They might have given you B. They might have given you C. Just depends on which one you're solving for. So I've got 115.22. So that's what changes. One gets an acute angle, one gets an obtuse angle. So will angle C be the same for each or different for each? It will be different. How will I find it for this one? Yeah, 180 minus 20.5 minus 64.78, and I get 94.72. Can I now find side C? How do I do that? I use the law of sines. Sine of 20.5 over 12 is equal to the sine of 94.72 divided by C. And I cross multiply. 12 sine of 94.72 divided by sine of 20.5, and I get 31.15. 34.15. That's my longest side. Does it match my largest angle? Yes, it does. Let's go to the B is obtuse triangle. Again, I can subtract from 180. 180 minus 115.22 minus 20.5, and I get 44.28. do I find side C? Law of sines. Sine of 20.5 over 12 equal to sine of 44.28 over C. 12 sine of 44.28 divided by the sine of 20.5, 2392. That's middle. Does that match the middle angle? Yeah. See that? Number one question I get from people is this. How do you come up with these two angles? Inverse sine and then subtract from 180. Yes. You don't. So in the beginning of the problem, right here, okay, here's what we know. You're given angle A, right? And you're given side A. So then angle B, that's the one you're solving for. So that will be the one will be either acute or obtuse. But if it would have said B here, then it would be A that you'd be looking at. You know what I mean? So it depends on what they give you. Question. Always. Always. And it does say that in your notes. It says when solving, if sine is less than 1, there are two solutions. At this point, set of two possible triangles. Triangle 1 will have theta be acute. Triangle 2 will have theta be obtuse. Simply sine inverse and then subtract from 180. So it lays it out there right there for you. Isn't that nice? Say, wow, Mr. Gintz, that's easy to follow. What a beautiful flow chart. You should sell that to people. I could actually charge maybe 10 cents from you guys for that. Like I make good $7 from everybody, huh? Okay. You don't think I'm funny at all today. I get it. I get it. There you go. There's your assignment. You will be given some time in class tomorrow to work on this, but please try to at least get to a spot where you're looking at one that has two solutions. No. This is the assignment that we have for today and tomorrow. I might give you, say, 2 more problems or something, but that will be it. Because I care about you guys. And I want you to learn. Tomorrow we will not go to the bell. Tomorrow will be short. We'll do a checkpoint at the beginning, and then we'll do 2 examples. That's it.